Unless you've been living under a rock, you know by now that Brackeys released his first Godot tutorial. And since this channel focuses mainly on multiplayer or networking topics, I decided it would be a fun challenge to turn his project into a multiplayer game. And since I've never really done a 2D game before, okay, I guess I've done a 2D game before, it would be a good experience to start with his project. Now, during this walkthrough, we're gonna look at a little bit more advanced topics, but don't worry, by the end of this video, you will have your first multiplayer game. And all the topics here are gonna be provided by Godot under their high-level networking APIs. So what does that mean? Well, we're gonna get a client and server from the INIT multiplayer peer. We're gonna get a multiplayer spawner, a multiplayer synchronizer, which allows us to replicate values between the client and server. We're also going to take a quick look on how to send a message with an RPC. We're going to touch on some server and client authority issues and also animate our character based on some synchronized variables. So if you haven't already, go grab Brackeys project, download it, fire it up. Let's dive in. The first thing I want to do is add a couple buttons to enable the multiplayer modes. But you may want to do this in a menu scene before the gameplay scene, but just to keep things simple for this project, I'm just going to put it right here. So head over to the game scene and add child node. We're going to add a control. Then we're going to add a panel. And then we're going to add a vertical box container. And then 2 buttons. Let's rename the control multiplayer HUD. And if we go up to the layout tab, transform, let's make a couple changes. Let's set the X on the size to 110, and we can set the Y to 35, and we can update the position to -110, and that should be good for our buttons. So select the first button and let's rename it to host, and name the second button join as player 2. And then we can name them join as player 2 and go under the theme overrides, select fonts, and then we can select the fonts that came with the project. I'm going to use the regular pixel operator, and then select the font size tab and change it to 8 pixels. And then for the host game button, we'll go under theme overrides again, select fonts. I'm going to select quick load, and then I'm going to use the bold one. And then we'll set the font to 8. And let's label this host new game. And if you select the panel and then the layout tab underneath it, select anchors for the layout mode, and then we'll just do full rect. And that way it fills it out nicely. Great, so now you should have 2 buttons there, host new game and join as player 2. Host new game is where you want to act as a host for other players to join your multiplayer game. And then join as player 2 allows you to connect and join to the configured IP and port of that hosted game. Now let's open up the game manager script, and we're gonna add 2 callbacks for these buttons. Okay, so we stubbed out 2 methods for the buttons respectively. Now let's select the first button, host game, select the node tab, double click on the pressed signal, select become host, hit OK and connect. Okay, and as you can see with this little green icon, we know that this function's been connected. Now select join as player 2, the node tab, double click pressed. We are under the game manager, so hit pick and select the join as player 2 function. Connect. Great. Okay, and let's do one more thing before we test these out. Go under project settings and the AUTOLOAD tab, and let's create a new AUTOLOAD called Multiplayer Manager. And save that under the scripts, and then create a new multiplayer folder and hit open, hit create. Open up that new script, Multiplayer Manager. So let's create 2 functions for becoming a host and join as multiplayer. We're going to use this multiplayer manager autoloader script to create our client and server, and also house the callbacks or lifecycle callbacks for when a connection has been established or disconnected. And we're going to keep it isolated in this one area so that if you want to change out your multiplayer implementation, you know where to find it, and it keeps the project structure nice and clean. So head over back to the game manager, and we're going to make a call to the autoloader to each respective button action. And before we move on, we just want to make sure that the UI is hidden after we select a button. So let's go ahead and hide that. So right click on the multiplayer HUD and select access unique name. Control drag over a reference, and let's just hide it. Let's do the same thing for join as player 2. Great. So let's just do a quick run to make sure that we have our buttons wired up correctly. Yep, starting host, and you can see the UI disappeared. So I'm just going to assume that join as player 2 has worked correctly. So let's go ahead and kill that and then minimize the multiplayer HUD. I think we're all finished there. So our game manager is complete. We are making a call to our autoloader, the multiplayer manager that we just created. When you click become a host, it calls the become host function there and the respective join as player 2 function as well. So we can move over to the multiplayer manager and begin filling out the become host functionality. So what we're going to do under the become host section here is create a server. And the reason why you need a server is to enable the multiplayer functionality, like sharing data back and forth to the other clients or players that are connected to the server. So the server kind of acts as the hub for sharing and making sure all the data gets distributed correctly, like where the players' locations are, or maybe what spells they're casting and that sort of thing. And there's another setup called hosting. And that's where, like, when you run a game, you also want to host the other players who are going to play in your multiplayer game can connect to. So you can run as host mode, and that is a client that also acts as a server so that your friends or whoever can join and also play you in that game. So that's what we're going to do today. We're going to set up a host mode. So it's going to be a client that also has a server and acts as a host. Let's create 2 constants to capture the server IP and port. This is going to be the port that your server runs on. And this is the IP of the server, which is just localhost. First, let's create our server. So right here, you'll see 2 options, one for create client and create server. We're going to select create server, and then we're going to pass in the port that the server will start at. So when we're hosting the game and we host this version of Godot, like we run the Godot game, we run it in host mode, and then we run it under this port. So when you're hosting the game, other clients can connect to that server. And then we're going to use a multiplayer API, which is provided by default by Godot. So what we're going to do here is establish that this instance is a server. And we do that by setting the multiplayer peer to the server peer that we just created above. And if you did nothing else and you just called this become host function and ran this code here, you would actually create a first instance of your server. Next, let's create a couple lifecycle callbacks to manage the connection of players. And we use the same multiplayer object. And we use the connect signal function so that we can add which function we want to call when a peer has connected to the server. I'm just going to create a function called add player to game when a peer connects. So what this means is when a player connects to your server, this peer connected callback is going to detect that and call this function. And that way we can set up that player and get them into the game correctly. And because this is a built-in lifecycle callback, it's going to actually pass in the network ID of the peer or client or player that just connected to your server. And we also want to handle when they disconnect to clean up the player and remove them from the game. You can do other things with this delete function, but for now, when someone closes a debug window, we just kick them out of the game. And the delete player function will also have the network ID of the player that disconnected passed into it. So let's do a print statement so we know who joined and left. Using a %s here is a nice way to print some variable in line with your print statement. And then we can just attach the variable that we want to print at the end of it here. Now that we have a server created, let's create a client. So now that we have the server running, we're going to have to start a client. And what that means is if you want somebody else to play, they need to be able to connect to the server that's running. And what we're going to do is provide them the server IP so they know where to connect to. And that's like when you build your game and you give it to other people, they're going to have a server IP that it needs to connect to, and it's going to pass through this join as player 2 function. For now, we're just going to look at focusing on testing on just a single computer. But if you did want to have your friend come over and play your game, you can actually build a version of your Godot client with the local IP of where you're hosting the game, like let's say on your computer. And then once you build it and give it to them, they'll be able to run this join as player 2 function, and it'll connect back to the host that you've run on your computer. But I'm not going to show that today. That's a little out of scope. Let's create the client peer. Select create client. And then when we create the client, remember, we need to know the server and port that this client is supposed to connect to. And again, when I say client, I mean it's somebody that has a copy of your game that's going to connect back to your server so they can join you in your multiplayer game. So we need to provide the server IP and server port of where your multiplayer game server or host in this case is running. And let's use the same multiplayer API to establish the client. So now you've completed a server setup and a client setup respectively. So now you basically have the bare bones network setup that will allow you to start your multiplayer game. And in order to test locally, go over to the debug menu and at the very bottom, select run multiple instances and select run 2 instances. And then what we can do to make sure that those debug windows always remain on top so they don't keep getting hidden every time you want to look at your code, go over to the project settings. In the filter settings, type top. And then if you select display window, just say always on top. If you don't like this, you can always undo it, but I actually prefer to debug and test like this. So let's run a test. So now you have 2 instances. Let's make the first one our host. So we say host new game, and then you can see become host is pressed and starting host. So let me move this over so we can see what's happening. As you can see here, starting host was hit, which means all this code was executed. So now you have a running server. Now let's say you want someone to join your game. What they need to do is select this join as player 2. And you'll see down here, player 2 joining, and then player, and then this long ID join the game. And what that is that means that this function was automatically hit because we have this signal here that was connected. So when that player wanted to connect, it ran this code right here, created a client with this server IP import. The server that we ran on this host instance ran this code, had this peer connected signal called to this when a player connected. And since we just connected from this instance, it automatically called this function right here, which is what we see here, player, and then the network ID join the game. That's exactly what this is printing. So now you have a server running with a client connected to it. That's the first step in getting a multiplayer up and running. Congratulations. But if we actually come over to the game and start jumping around, you'll notice that you don't see the other player. So why not? Well, we have to add the other player to the other session, right? They don't just automatically get synchronized. So let's dig in and see how to do that. And I'm actually going to turn the music off for this demo because I don't want to keep hearing it every time we run it. So let's go ahead and select, you can uncheck autoplay here if you'd like. It just helps when you're debugging to not hear the same thing over and over again. Before we can add our friends to the game, what we need to first do is create another scene that is a multiplayer version of the player. I don't want to reuse the player code that Brackeys created for you. I just wanted to keep it separate so that it's easy to manage. So let's go over and create a new scene. Let's call it multiplayer player. And it's also going to be a character 2D, just like the player scene. And then while we have that open, let's just create a script that we're going to need shortly. And this script will be what controls the player movement. We already have one for the single player version called player. I'm going to name this multiplayer controller. And let's save it under the scripts multiplayer folder. We'll just put that on the back burner for now. Open up the player scene that came with the project. Copy over the 2 nodes that are underneath it. And let's just paste it under our new multiplayer player scene. And we also want to grab the camera. So go back to the main game scene, grab the camera 2D, and paste it in there as well. And we'll talk about why in a minute. Now let's look at how to add a player to the game. We're going to instantiate the multiplayer scene that we just created, but we actually haven't added it to the script yet. So let's establish that at the top. Type scenes and then scroll down to the multiplayer player scene that we just created. And this scene is going to represent every new player that enters the game, whether you're on host or client. And that's what we just instantiated right here. And when you get connected to the game by hitting this add player to game function from our peer connected callback, we instantiate that new multiplayer scene that represents our character. Since we have the network ID passed into this callback, we're going to set the player ID equal to that network ID. And we're also going to establish the name that's set to the same ID. And we do this to make it easier to detect authority as we're working through our game. And we'll talk about that more in a minute. But we don't have a player ID yet, so we need to add that to our multiplayer object. So let's go back to the multiplayer controller and establish that player ID. And we set up the player ID so that it will default to 1, and 1 for any player or peer is always going to mean the server. So we just easily default that to 1. But when we have any other peer except for the server, we need to establish that player ID. And we're using this set function because we actually need to establish some authority, but I'm going to show you what that looks like in a minute. So now we have our player ID and name. Now let's add the player to the actual game scene. So how do we do that? So if we go back to our game scene, the way that we're going to add players to the game is through something called a multiplayer spawner. So let's go ahead and create a multiplayer spawner. If you click on the yellow warning, what it's telling us is that it needs a spawn path in order to spawn the nodes into. So if we click on it, you'll notice that there's a spawn path that we need to set. So let's create a node where our players can spawn into the game at. So we'll create a 2D node and we'll call it players. And we'll select our multiplayer spawner and drag that players object right there. So what this means is the multiplayer spawner has a target of where to spawn the objects you wish to spawn there. And because we're spawning players and this is a 2-player game, just move this up to 2. You can actually support more than 2 players, but for now we just leave it at 2. But the multiplayer spawner also needs to know what type of object to spawn. So if we hit add element, let's select the multiplayer player scene that we just created a minute ago. We'll go under scenes, multiplayer. So now what this is telling the multiplayer spawner is when it detects a multiplayer player scene, this guy right here, when he detects one of those nodes added to this players node, he's going to automatically spawn that on all the connected peers or clients or players that are in the game. So if you start and you have a host, your player will get added to this through code, which I'll show you in a second, and then he'll automatically spawn and sync that player to the other clients that are connected to that host. So if we go back to the multiplayer manager, let's grab a reference to the players node. So let's establish a variable at the top. And when you start a host, we need to grab a reference to the current players node. And then we'll just type in the name of the node, which is players. And what this does is it gets us the entire tree when the game is running. So it's going to be this whole thing. And then we get the current scene, which is the scene that we're running in this game scene. And then we get the node within that scene that's players. So it'll actually return this object. And the reason why we get a reference to it when the server is started or when the host is started is because in single player mode, if you die, the game is actually set up to refresh the whole scene. And if you try to get that at the beginning of the game and you die, the reference won't be there anymore because the scene was recreated. So it's not going to be accurate. So we have to do this every time a new server is started. So when you go from single player mode to multiplayer mode, that's it. You're in multiplayer mode and that scene is locked there. So we're not going to refresh any scenes at this point. And we only need to establish this on the server side because the server is where the actual players are getting added to the game. So let's grab a reference to the player spawn node and down under where we actually are creating our new player. Let's paste that and say add child. And let's just add in the player we just created. So what this does is it adds this new multiplayer player scene that we just initialized, which just represents our new player, and it adds him as a child underneath this player's object. Then the multiplayer spawner is going to detect that because that's what we told it to look for, and it's going to actually spawn and sync that player throughout all the clients that are currently connected. So let's run a quick test. If we hit host new game, we have a little player, and if we hit join as player 2, you can see there that there's another player added into the game. Now you might be thinking, why is there 2 players? Is this working correctly? Well, it's actually not the host player at all right now. We haven't been able to successfully synchronize that because we still have the old single player mode enabled. So we need to actually remove the single player version of the player from the game. So let's create a function to remove the single player. And just like what we did before when we grabbed a reference to the players node, we're going to grab a reference to the current player mode. And we have to do that at the time when we actually need to remove them. And that's why we grab that reference right here in the function and not establish that earlier, because if you die again, it can refresh the scene and it won't be the correct context. So we'll go ahead and remove them from the scene with this call to queue free. So we need to add that under both sections. When you're joining as a client, we need to remove the single player version of the player. And also when you become a host. Okay, let's run and see what happens. Host new game. Oh, it looks like we have a bug here, but let's see if we join as player 2. Oh, look at that. Player 2's joined in the game. So why didn't the host mode work, but player 2 worked? Well, I don't know if you've caught on to it yet, but what happens when you join host, it doesn't actually hit this peer connected callback. So we have to manually add the player on host mode to that server. So we'll just make a call manually right here. We'll pass in the ID of 1 because the server or host is always going to have a network ID of 1. So now let's see if the player joins the game. Host new game, and there he is. You can see he's in the game successfully. And if we join as player 2, oh no, we've got a little bit of a bug there, but why did that happen? Well, let's just take a look. But you can see there's actually 2 players in the game now. But because we haven't established or set up something else, we've got a little bit of a bug. But we now know that both players are in the game. Oh, and if you want to debug and see what that would look like, head over to this remote tab and select this game dropdown. And if you hit the players dropdown, you can see there's actually 2 players there. And if you notice, there's no other player from the single player mode in the game scene. So you can see there's player 1, which is our host server player, and then our client peer player, this one that's joined right there. And if you go under the debug tab, that's for session 1. If you click on session 2, that's going to represent the other debug window respectively. And you can see that window also has 2 players joined as well. So we know both players are joined in this multiplayer game. So good job. So before we move on, let's also handle what happens when a player is removed from the game. So what this function is doing is it's grabbing a reference to that players node here, and it's seeing if the one that left exists in this players list. And if it does, we'll go ahead and kick them out and just remove them from the game to clean it up. And if we test that really quick, whoop. If we go over to the remote tab, we drop down this thing. If we click this, you should see them removed from the game. So that's exactly what that looks like. So now that we have a network connection between a server and a client peer, and both players spawn in the game, we need to figure out how to synchronize their location. So let's go and build out the multiplayer controller. So open up the existing script that came with the player, and let's just copy everything that's in this physics process function. And let's copy and paste it over into the existing physics process just to get it over there in the script. And we need to add a couple variables from that script as well. So let's copy over the animated sprites, paste that up here. And we also need to grab the updated speed and jump velocity. Next, let's create 2 functions, one to handle the animations and another to process the player's movement and apply them to the actual player object. So the first thing we want to do is copy over the animation code from this physics process code that we just copied over. So that's going to be everything down to there. Paste it up here. And then let's grab everything to process the player's movement and move that into apply movement from input and paste it in there. Okay, the first thing I want to do is remove this direction because there's no reference to it locally anymore. So let's reinitialize that at the top here. And now our apply animations will have a reference to it. And with this current setup, right now we are processing the player's input right in our multiplayer controller here. And we want to move those inputs to another location because we're going to give it a different authority. So what do I mean by that? Well, in a multiplayer game, everything is default server authority, meaning you have to be on the server to be able to make changes to things that are networked or synchronized across the other clients. But how can a server press the spacebar button or move the mouse for you? Well, it can't. So we need to create a node that handles the inputs and gives authority to the client to be able to pass those inputs to the server so that the server can take those inputs and apply it to the player object. So before we do that, let's make sure we open up our multiplayer player object. And we're going to create a new node called a MultiplayerSynchronizer. So hit add child node, type in MultiplayerSynchronizer. And just be sure to move that under the top there. We're going to call this input synchronizer. We're also going to create a script to assign to that to handle the player's inputs. Let's move it to the scripts folder, multiplayer. And let's change the name to multiplayer input. So in order for the server to know which keyboard or mouse inputs the player is pressing, we need to be able to synchronize that back to the server. So we just created a input synchronizer, but let's synchronize the variable to handle those inputs. So the first thing we want to do is capture the input direction, which is which way is the player moving, left or right. And if we go back to the input function that we just copied over, that's going to map to this. So let's go ahead and copy paste that into the input direction. And let's establish it under the ready function here. And let's just set it equal to input direction. So that way, when this scene loads, we have an established input direction. And then we need to implement the physics process function. And then there, we're going to calculate the input direction that the player is actively hitting. So that is going to replace this call here. So we can remove that. But first, we need to grab a reference to our input synchronizer. So let's access unique name, drag over and hit control. And then we'll say paste in input direction. So that'll replace that. So now we can get the input direction that the player is currently hitting from our multiplayer input script here. But if you notice, this apply movement, we want it to only be called on the server side. So if that doesn't make sense, well, just look at it like this. We want the server to be in complete control of where the players exist on each other's client. We don't really want to give them complete authority because they can cheat, right? So what we're going to do in this setup, now your game might be a little different, but in this setup, we're going to just tell the server what the player wants to do from keyboard and mouse inputs. And then the server is going to say, okay, and apply those movements based off that input to the actual position of the player. So we need to make sure that that apply movement from input script is only ran on the server. So under this physics process function, we need to call to that apply movement from input, but let's first wrap it in a check using that multiplayer object that we talked about earlier. We'll say is server, and then we can make a call to that apply movement. So what this ensures is that we're not going to run any calculations to actually move the player on the client. It's only going to run on the server. But the server isn't going to know about this input direction yet because we need to replicate it from the client back to the server. So to do that, make sure you have your input synchronizer selected and open up this replication tab. And we're going to type in input synchronizer colon and then input direction and then hit enter. So now this means that we are replicating the input direction. However, there's one more step we need to do before the client can actually tell the server what inputs it's making. We need to give that multiplayer input script client authority. So the client's in charge of what's happening. So go back to our multiplayer controller and remember when I said I left that space here, that's exactly where we're going to give the client authority over its inputs. So take that synchronizer and do set multiplayer authority. And you're going to pass in the ID. So what that means, if we go back to our multiplayer manager script that we started with, when a player is added to the game, right here when we set the player ID, it's calling back to the multiplayer controller because it's establishing this player. It's setting the player ID. So when we establish the player ID, we also take that network ID, which is the ID here, and we set the authority based on that ID to the input synchronizer node here. So any scripts that's attached to this input synchronizer, which is our multiplayer input, will have client authority. So that's how we establish or change authority using this set multiplayer authority function. So if you needed to change it at some other point in your code, that's how you would do it. But this right here is a good setup for how to establish client authority over the inputs in the video game. And that way we're not giving authority over the entire player object here. We're just doing it over the input. Now you can give authority to the player over the entire object so that you can actually control the player from the client and then just send those positions to the server. And then the server takes those positions and synchronizes it to the other client. But that's not server authoritative, meaning your client could kind of mess with the player's position. And we don't want to do that in this setup. We want to make sure our server is keeping guard and watch on what the player is doing. So we're only going to give the client access to change things like the player input. So now that we have the authority set for the input synchronizer, we also have to just do one more thing in the ready function here. We don't want the server instance of this object to be running the process or physics process. So let's go ahead and disable that. So what we're doing here is we're saying who's the authority? Well, we just set it here, right? So it's to the network ID of whatever client is actually playing the game. So if that authority, let's say the authority ID is 1234, is not equal to the current peer it's on, this is going to give us the current ID or network ID of the peer that this object is running on. If they're not equal, then we need to shut them off because that means it's not running on the local client's computer. So that's what this is going to do. So in reality, what that means is it's probably running on the server somewhere, and we don't want that to happen. We want the physics process and process to only run on the client in this setup. Now, you can change this for your game as your game requirements evolve, or maybe you have a different setup than this, but for this demo, that's what we're going to do. So we're pretty close to being able to test. And you remember this player ID? Well, this player ID needs to be able to be synchronized back to the client so that the client has, a context of how to operate and what authority. So let's go ahead and synchronize this player ID. So what we're going to do is underneath this multiplayer object, let's create another multiplayer synchronizer. We're going to actually also synchronize a few other properties in a minute. But first, let's just add in the player ID. Because we're exporting this, I think we can hit this add property to sync, select the multiplayer player object, and you can see the player ID listed there and just hit open. And now it's going to be synchronized. So because this multiplayer player object has server authority by default, when we look at the multiplayer synchronizer here, that replication will be from the server down to the clients. Let's just actually rename it really quick. I'm going to call it player synchronizer. So let's do a quick demo to see where we're at. Click host new game. And you can see we have our host player jumping around just fine. Animations aren't working yet, but we'll get to that in a second. And let's join as player 2. So player 2 drops in and you can see them in the actual host screen, but you can't see player 1. So we still have some issues to work out here. But if we actually jump, it's jumping on both of them because we haven't wired up our jump correctly. But if we click on the client and we move, you can see he's only moving in the top one. So he's not moving on the bottom one. Now, why is that? Well, it's because we're not actually synchronizing the movements of the player back down to the client yet. Now we're synchronizing the inputs because you can see he's actually moving on the server, but we're not actually synchronizing those movements back to the client. So let's look at how to do that. So select your player synchronizer, hit replication, and let's synchronize the position of the player. Scroll down to no 2D position, hit open, and let's hit play again. Host mode, now he's in, and let's join as player 2. And now if I move our mouse inputs, now you can see he's actually moving on both clients, the client that he's on and the actual host. So what's happening is when I move on my client down here, that input is sent to the server, processed and applied to the actual player object on the server, and then synced back to the client. Now, if we had multiple clients, you would see him move on all clients, that player 2 object. So we don't have jump working yet because we haven't wired it up, but let's go ahead and look at how to do that. Let's create a new variable in our multiplayer controller called doJump. And we also need to create another variable that we're going to synchronize called isOnFloor. And we'll use that in just a second. Let's also replicate these two fields as well. You can just copy doJump, paste, hit enter, and it shows up. And then we'll do the same with isOnFloor. So if we scroll down to where we process our jump currently, we still have this input handling here, and we don't want to handle that. Remember, we want to move all our player inputs to the multiplayer input script. So let's grab that, go to the multiplayer input, and down in the process function, let's just add it right there. Next, we need to create an RPC so that we can send a message to the server that the player wants to jump. Okay, so there's a lot to unpack with what we just did, but we created a typical function and then we added this RPC annotation with a parameter of call local. So what this does is it takes a normal function like jump and turns it into a remote procedure call. And RPCs allow us to send messages between the client and server respectively. Now you can create some RPCs that only call from the clients to the server and others that only call from the server down to the client. And in this case, because we have a setup where we have a host where he's a client and a server, we need to add this call local annotation here so that it can actually call to itself. And that's why we add this if multiplayer server call is here, because we want to call it from the client. So let's do the call. And that's how you call an RPC. You put the name of the function followed by RPC. And if you had any parameters to pass, you can actually put them right here. And then of course you'd have to declare those parameters here. We also need a reference to the player object. And down in the jump function, we wrap the set of doJump to true with a call to multiplayer is server. This is going to check to make sure that we are operating on a server because you can actually set doJump on the client. So when we make this RPC call, in theory, it can be called locally now because we set this call local, but we only really care about that local thing because of the host mode setup. So we want to ignore the local call of it when a non-host setup, so like the other client that's connected, they would actually hit the jump locally on their client, and we don't really care to do anything with the jump. Maybe in some setups you could kick off the jump animation here, and that's something to think about, but that's a little out of scope here. But for now, just realize that we want to set the doJump variable on our player, but we can only do that in the server context. So that's what we're doing here. So we're processing a request to jump on the client. We make a remote procedure call or RPC to jump, and then that jump sets the doJump variable to true. So back in our multiplayer controller, let's replace this input handler here with doJump. And since we don't want the jump to keep repeating, we need to set it to false right after it jumps. And since we are replicating that doJump object, when we set it on the server side from our client input right here, it'll actually synchronize back down to the other clients that are connected to the game. So if we're going to leverage this doJump for other things like animations, we'll have access to it. In this case, we aren't actually going to use it, but it's just a good practice to have it set up this way. Okay, so let's do a quick test because I think we have our jump logic working. Host new game, okay, and join as player 2. And look at that, we have our jump logic working. You can see that it's being synchronized on both screens. Look at that, awesome. Our animations aren't working yet because we haven't set that up. And you also notice that you can see it's not following, the camera isn't following the correct player. So we also need to set that up too. But we're getting pretty close to have both players synchronized correctly. So back in our project under the multiplayer controller, let's create a ready function. Ready is called when the player object first enters the scene. So it's a good place to do some initialization or whatever setup for the player object. And because this multiplayer scene has a camera, we don't actually need to have the camera run on the server's version of it. So let's just make sure that it only runs on the client. So that's exactly what I'm doing with this check here. I'm making sure we're on the correct client, meaning the local player playing the game, by checking what his unique ID is and making sure it matches the player that we're currently playing as. And if it is, we set the camera to current. So that's our camera. And then any other instances of this player, we're just going to go ahead and disable the camera because we don't want to confuse anything. So let's run again and make sure that fixed it. Okay, so the host setup of the client is following correctly. And let's see down here, join as player 2. And you can see that it's following this player correctly. Now you have both clients successfully syncing their position and jumps as we move about. Now let's look at how do we fix the animations, because right now they are not working. So you remember before when we pasted all the animation logic in this apply animation function earlier? Well, we're not actually calling that yet. We need to come down to our physics process method and let's make a call. But we only want it to run on the client version of this physics process. So let's make sure we're not on the server. So it's going to call to our apply animations. So it's going to get the direction and determine which way we face. And then if we're on the floor, it's going to determine which animation to play based on whether we're jumping or not. So let's do a quick test. And as you can see, it's still not working on our host, but let's see what happens when we join as the client. So he's not really working either. So what's going on there? What do you think the problem is? Well, we're not actually synchronizing the direction variable here. So when this runs on the client, it doesn't actually know what the server thinks the direction is. And also, we're not really sure if we're on the floor or not. And that's why they're all stuck in the jump animation, because this floor, he can't detect it on the client. So we need to be able to synchronize that is on floor function, or that is on floor value that we created earlier. So we need to be able to synchronize the state of whether or not they're on the floor. Select our player synchronizer, and then we're going to add the direction property. And if you remember, direction is set under the physics process call to apply movement from input right here. And it's getting set here on the server side from our client input. So that is going to be synced from the server down to the clients. And that direction will be able to be correctly gathered on the client side when we're calculating which direction he should be facing. But we still need to check, is he on the floor or not? So let's change this to is on floor, which is that variable we created earlier. And since we're already replicating it down here, we should be good to go. So let's do a test again. Okay, let's run host and let's run client. Okay, and as you can see on the host side, he's able to jump and everything, and he's not stuck in the jump animation, but he's still not showing the correct position. However, he is correctly showing on the client. And let's see what the client does. So the client can jump, but he's still not showing his correct animation. And then when he turns left, it's actually working correctly on the client, but not on the server. So let's see what's going on. So what's happening is down here where we add this check, if not on server, the problem is because we're running one of the clients in host mode, technically that's still on the server. So we actually need to run those animations on that server. So this kind of puts us in a tough situation, but an easy way to resolve it to check if we're in host mode, let's create a variable back in that multiplayer manager that we created a while ago. And let's call it host mode enabled. So when a host mode is enabled, let's just paste it in here and set it to true. So that way we know when we're in host mode, but we also need to do some client operations. We can easily just check for this variable. So back in our controller, let's say or multiplayer manager. Now let's try it. And you can see his back and forth animations are now working correctly. Looks like his jump animation isn't working correctly, so I still think we need to do one more thing there, and let's just make sure on the client that everything is okay as well. So it is successfully synchronizing the direction, so the only thing that we have left to do is, how come the jump animation isn't showing up? Well, it's because we're not actually setting it. So back under our physics process here, right before we apply the movements, let's also synchronize the is on floor status. Okay, so now if we save and we run, the is on floor should be correctly able to determine which animation we should be playing, the run or idle or the jump. And look at that. So when I jump, he tucks back into the jump animation. And I'm going right, he turns right, he goes left, he turns left, and so on and so forth. So I think we've got that fixed. Let's just double check on the client. And look at that. So everything seems to be synchronizing correctly. The camera's in place, the jump animations, the right or left turn animations are also working. And one thing to note right here is you'll notice he's being able to stand on each other. That's because we have a layer not set underneath our multiplayer player object. So let's go do that really quick. Unless you want that, you could totally just leave this and they can collide earlier. But if you also notice, they're not hitting the coins anymore. So let's go ahead and stop that. Select the multiplayer object under the collision tab, set the layer to 2, and then remove the first layer selection. And now the coins and players should collide and not collide respectively correctly now. Let's see. Okay, if I should be able to pick up coins, great. And let's see. Great. So can he pick up coins? Great. He's got coins. And let's see if I can jump on them anymore. Great. No, so we're not colliding anymore. Now that's something that you would have to play around with if you want your game to have that functionality. You know, is it a bug or a feature kind of deal? But I think we've got it working. So at this point, you have player position synchronized correctly. You have the jump and animations working from the client inputs. So this is a pretty complete example. You could stop here if you want and make whatever adjustments you want to your game. But I actually want to finish this out a little bit before moving on. And what I want to do is synchronize this platform because I think that's a really important thing to illustrate here. So in a multiplayer game, things like moving objects or whatever, that's not going to really work, right? So it's going to work on the server. So on the server side has authority. So it's going to think that this is the correct location of the platform. But the client, let's move it down here, it's not in the right spot. It just falls right through it. And if you notice, the whole scene reloaded when I died. We don't want that anymore. So we're going to also have to edit that. So let's look at how to synchronize the platforms and then adjust the logic to the players when they die. And then we're also going to just create a little finish line thing. And don't worry if you're feeling a little confused or overwhelmed by all this authority and checking for a server or not, and what's a client, what's a server. I'm actually going to put together a basic fundamental series on this multiplayer stuff. So now's a good time to make sure you're subscribed so you don't miss out. Okay, so let's open up the platform scene. So let's create a script and attach it to the platform. And you can just leave the platform name as default. There is fine. And we can remove the process function. And the first thing I'm going to do is add another multiplayer synchronizer. So type multiplayer and select synchronizer. And let's just call it platform synchronizer. I think there's a bug about the location of this, so I like to just keep them at the top in case that bug is actually real or not. Okay, so the first thing I want to do is synchronize the platform's position. So let's select add property to sync, select the platform, under 2D, hit position, and hit open. Great. So now we have the platform position correctly synced, but it's still not going to work. And the reason why it's not going to work is because if we go under the game scene, look at the platforms, you'll notice that the platform motion for the one that's actually moving is moved by this position animation here. So that means on both clients, the animation player is going to take over. So in order to get around that, we need to stop the animation player on the client side. So there might be a couple ways to do this, but what I'm going to do is check that if there's an animation player associated with a platform, then we can assume or make that assumption that we're going to actually need to synchronize this. So we shouldn't be playing the animation player on the client. So let's create a field to check whether or not we have an animation player. So now we can export and change that from our nodes. So if we select the platform, let's go ahead and assign that animation player there. And then in our ready function, let's check if it exists. And then if it does exist, then I want to set up a multiplayer callback for when a client connects so that we can kill the animation player when that client actually connects. So this will be similar to the multiplayer callbacks we used earlier, just in a different context. Then let's create a function called onPlayerConnected. And then let's make sure we're not on the server because we only want to disable this on the client. And then we're going to stop and disable the animation player. So let's see if it works. Host new game, join as player 2, and let's run over as the host first. Okay, there's the platform. Let's see if it's actually synchronizing correctly. Let's line them up a little closer here. You can see that they're lining up exactly where they should be. So the position is being synchronized from our server host on this client or this host client. And you can see I can land on it. And now let's check to see if I can land on it from this guy. I'm getting really good at this game. And there we go. And you can see now the platform has been correctly synchronized just through some simple adjustments here by detecting whether or not there's an animation player. Now, again, you can probably handle this in a couple different ways, but I thought this was really straightforward. And now we have a synchronized platform that we can jump on. So as you can see here, the monster is definitely not synchronized, and I'm gonna just leave that for you guys to have fun with. Okay, so let's rework how we do the kill processing. So if you jump and you die, it'll actually restart the whole scene, and that's not what we want anymore. Let's open up our kill zone scene, and we have the script there loaded. So I want to keep this logic here for the single player game. I don't want to touch that. So we need to have a check in there that says, is multiplayer mode enabled? So let's go back to our multiplayer manager. So let's add a variable back there to be able to check if multiplayer mode has been enabled. So regardless if we're running a host or a client, multiplayer mode will be enabled. So we can just go ahead and copy that and also paste it down under join as player 2. Okay, so back in our kill zone, when a body's been detected, let's just check if multiplayer mode's been enabled. And if the multiplayer mode has not been enabled, we'll just continue on with the single player mode cleanup here. So if we are in multiplayer mode, let's create a function to handle that. Now we want to make sure that this check happens on the server. So like everything is default on server, but things will run on both client and server unless we specify otherwise. So let's just make sure we do a check to make sure this is only happening on the server. And we're going to do something really similar with the engine time, but because this is a multiplayer scenario, we're not just refreshing the scene or restarting the scene. We need to handle it a little differently. So we can put the engine time scale here. And then we need to make a call back to our player object with a new function called markDead. So let's create that function under the multiplayer controller. Let's just scroll down. So let's go ahead and disable the collision shape here. So let's get back to our multiplayer scene, drag over that collision shape. We're going to disable it using a call to set deferred, as the docs recommend doing it that way. And we're going to set it to true, so it is disabled. And we also need to kick off a new respawn timer associated with the actual player. Now, the reason why I didn't want to add it inside the kill zone anymore for the multiplayer setup is because you'd actually have to keep track of who died when and where, because, you know, both players can die at the same time, and it becomes a little bit difficult and maybe just unnecessary to keep track of that complexity. So I'm just going to let the timers be specific to the actual player object. So underneath the multiplayer object, let's create a new timer. And we'll just call it respawn timer. Drag that over and we'll start it. And let's create another function that will get triggered when the respawn timer times out. And let's re-enable our collision. And then let's wire up our respawn timer. So now when the player hits a kill zone and it's in single player mode, everything just continues as Brackeys had originally set it up. Otherwise, we hit this multiplayer dead setup and we make sure we're on the server and we call this markDead function on our player object, comes over to the markDead function, disables the collision shape so they'll fall through the ground, and we hit that respawn timer. And then once the respawn timer is complete, we go ahead and re-enable the collision shape. Okay, and make sure under the respawn timer, you have the one shot selected. And I think our wait time is about a half a second, 0.6 seconds. I think that's what he originally had. Let me double check. 0.6. Yep. Okay. So let's just do a quick demo to see where we're at. Okay. So I'm in the game, join as player 2, and let's just jump to my death. All right. So I'm not respawned. And also I'm getting a bunch of spam here. Mark player dead, respawn, respawn. So something fishy is going on here. Well, the first thing is, where is the player? Why isn't he getting respawned to the correct location? Well, because in the single player mode, we're just reloading the entire scene. So the single player and wherever he's at just gets reset back to the beginning. Well, we need to actually set a spawn point where he needs to come back to life at. So let's see how to do that. So back in our multiplayer manager, scroll back up to the top. Let's create a spawn point here that we can access. Now you can do this a couple different ways, but just to be easy, I'm going to let the multiplayer manager handle where players get spawned back in. And I determined that this 30-20 mark is actually pretty good to the start of the level. Let's copy that and over our controller. So once the player respawns, let's go ahead and move him back to that start point. And we just update the position of the actual player character back to the original part. And the way we do this is just set the position to that respawn point that we just set. So it'll basically just teleport him back to the beginning. Okay, let's test again and see what happens. Okay, join player 2, and let's just jump. Okay, so he's respawning, but we're in a weird loop again. Oh, he made it back. Let's just see what happens if I die again. I actually know what happened, but it took a little bit of research to figure out. But apparently what's happening here is there's a bug when you disable collision shapes and re-enable them during the process of hitting an existing collision shape and moving the player. Yeah, it's like a very specific thing. And I stumbled upon a bug. I found it on GitHub, as you can see here. And anyways, to fix that, to work around that, I thought it would be a good idea to have a flag that will set whether or not the player is dead. So let's just do that. So if we go to the top of our multiplayer controller, add a new variable, alive, we'll set him to alive as true. And then down in the mark dead function, we'll set him to dead. Okay, but first what we need to do is make sure that we don't spam the kill zone logic to mark him dead over and over again, kicking off that spam down here, marking player dead, marking player dead. So let's check, okay, he's on the server, and we also need to make sure he's alive. So what we're gonna do is the first time this mark dead is called, he'll actually come in here and it'll check, okay, is he alive? Yeah, he's actually alive. And then the second time it'll come in, because of this bug, it's gonna keep detecting in this onBody entered. He's gonna say, oh wait, this guy's actually dead already. We don't need to run this anymore. So do body.alive, and then that should resolve that problem. So let's see. Okay, let's just join player 2 just to be sure. And if we jump, look at that. He comes right back to life, but it's like he's swimming like in the Mario swim levels. We just accidentally created that. Well, what we did is we slowed down the engine time here, but we never sped it back up. So let's speed it back up. So let's just copy this engine time scale to 1. Let's close our game. Let's go back to our multiplayer controller. And we actually need to create another function. Function set alive, print alive again. And we'll set alive equal to true here. And we'll set the engine timescale back to 1. So you're probably wondering, what's this set alive function? Well, once he's respawned, you can't actually just set the alive variable back to true right here. It won't work. We actually need to give the physics process a chance to reestablish the collision shape to avoid that bug. So up here under our physics process, if we're on the multiplayer server, let's just add a check right here really quick. If he's not alive, and he is on floor though, meaning he died, he fell because his collision shape was disabled, and then we put him back with our respawn point so that now he's back on the ground, and then we enabled his collision shape, so he's going to be dead, right? He's going to be dead, but he's now going to be on the floor. At that point, we can successfully say, let's get him back. Let's get him back to life. So at that point, we do a call to set alive, and down there, we'll go ahead and set him back to alive, and then set the engine scale back to 1. So now it should work. Okay, let's die. And we're back to normal. Perfect. Let's check with player 2, and we'll die. And we're back in the game. You can see he just drops in over there. So I think we've got the death code working again. And this little like hack that I did is, you know, it's some of the stuff you're going to have to run into when you're developing and making games. There's not always going to be 100% support for something, or there's going to be a bug. So you'll have to find these little workarounds. So the next we want to do is let's add a finish line at the end of the game so that we can determine who won. So let's go back to the main game scene. Let's add another area 2D. Let's call it finish line. And then we need to add another collision shape 2D. And under the shape parameter, let's select rectangle. And let's go back to our 2D game world. And here is the rectangle. So you guys can put this wherever you want the end of the game to be. I want the end of the game to be right here. So the first person to pass through this area wins the game. And to make things really quick, let's select our finish line object and let's just create a new script. Call it finish line. Save it under the scripts folder, not the scenes. Okay. And we can remove all that. And let's just create another callback for onBodyEntered. And what we need to do is make sure that multiplayer mode is enabled. We don't really care to hit this in single player mode. Whoever runs into that collision, that finish line collision, we want to make sure that that's the player that is locally playing with their computer, right? So their instance of the game. We don't want to run this code because this is a multiplayer game. This code is going to be executed in multiple contexts. We just want to make sure that this will only get triggered on the player who actually collides with that collision shape under that finish line object. So we're going to check that the current player using the multiplayer API, that the current player is actually the player that collided with the collision shape. Okay, so now we need to add the callback when the collision happens. So let's do onBodyEntered. Scroll down, select the finish line, hit pick, onBodyEntered, okay, connect. Great. And one more thing we need to do before we're ready to test is select your finish line object, go under the collision shape and set the mask to 2 so that we actually collide with the player, because remember the player is on layer 2. So let's run that. Create a host, join as player 2. Let's just say player 1 gets ahead of everybody. Great. So you can see there player 1 wins. So that's player 1 wins, right? So I know this is a little cheesy, but it just prints out who won based on the client that actually wins it. If you guys want to take this a step further, whoever crosses that finish line, you can actually make an RPC call to both clients and say and pass the ID of the player that won. And then you can pop up a message that on each respective client or each respective, player that's playing the game and say player whatever wins the game and then you lost or that sort of thing. So this kind of gives you an in to be able to do that. And I just wanted you guys to have that. So that's pretty much it for this demonstration. We have a working multiplayer game that is synchronizing 2 players at this point. We have a platform that is synchronized across the 2 clients. Our monster isn't, so it's going to be harder for player 2 because I don't know. Oh, see, I just died because I didn't know where the monster is because we're not synchronizing. So, where do we go from here? Well, you guys can work on synchronizing the monster. You can really take this game to really anywhere you want it to go. Maybe count how many coins are collected and synchronize that and have a little label at the top that's synchronizing the coins. I know there's a little bit of lag in the actual players when you're running, and we can apply some smoothing efforts using lerp on the client side so that when the client side is getting a position, you can actually lerp between those positions so that they're not so rigid. Now, you probably can't leverage the actual underlying position at that point. You probably have to synchronize a different position variable that you can go ahead and replicate. But I think that would be the next step here. And there's some other improvements to it that are a little out of scope for this, but I think that's the next place that you can take it. So if you enjoyed this video, please give it a like. I would love to make more videos like this. So if you did like it or you want to see more, also subscribe. It really keeps me motivated. And again, I've got a lot more multiplayer videos on the way, including a couple of fundamental ones that I want to put out soon. So if you're still struggling with this, well, don't worry, stay tuned, subscribe to it. And I'm going to try to make all this multiplayer stuff really, really easy to understand. So anyways, thanks for watching.